The next program for schools and colleges, Exploring Science, follows in 2 minutes.
Autumn, time to turn the soil ready for the new season's crops. Perhaps for fields of wheat, or maybe fields of grass where cattle can eventually graze. Most people probably think of soil as something in which plants are grown. Without the growing plants, nothing seems to be happening. But what's this? Tunneling away just below the surface is a mole. It's an animal that's quite difficult to film, and we needed a special lens to do it. Moles are just some of the many animals that spend most of their lives in the soil. Worms are others, and worms are a popular food with moles. In this dark underground world, the mole can't see its food. Instead, it tracks down the worms by sniffing and listening. The moles have a very good sense of smell and hearing, which means they can detect the very faint smell and tiny noises that worms make. Obviously, there is life in the soil, and naturally, that life depends on food. Moles eat other animals, mainly worms. But what do worms eat? They come to the surface to get their food, dead and rotting plant material. Dead leaves are the worms' most common food. They pull the leaves back down into their holes or burrows, ready for the next meal. Worms are very important to the soil. For instance, their waste adds to the soil. On the surface, we see their waste as worm casts. Worms help make the soil in which they live. Because worms and moles live mostly in the soil, they're very difficult to find. Many of the other soil animals are much smaller, which makes the problem of finding them even worse. Let's start by looking for those animals that live in the top layer of the soil. One of the best ways is to scrape up the loose surface soil together with some of the leaves and take it back to the laboratory. Spread it out on a white tray, then watch carefully and patiently. Some of the animals are pretty fast moving, but if you're quick, you can trap them using a straw. No, not one straight in your mouth. It first goes into a bottle. A piece of gauze prevents the animals being drawn up out of the bottle into your mouth. A woodlouse, a very common animal in the top layer of the soil. The sample also contained a millipede, an animal with 2 pairs of legs on each piece of its body. And a centipede. Centipedes have just 1 pair of legs on each piece of their bodies. And a spider, lots of those near the top of the soil. Another way of catching, sampling the animals in the top layer of the soil is to make a pitfall trap. By burying a plastic cup with the lip level with the surface, it's possible to trap any animals that may be walking in the top layer. The animals fall into the cup, and because the sides are steep, the animals can't get out again. The trap is covered to keep out the leaves and left for 24 hours. Next day we found 2 beetles and a millipede, a fairly typical catch. But of course there are animals that live lower down in the soil. If we want to find them, we have to use a quite different method. This piece of equipment is called an auger. It cuts out a solid chunk of soil to a depth of 15 centimeters. To sample the contents of the soil scientists don't just rely on one sample, but take several from the area under study. Each sample is stored in a tin for later examination. Soil scientists want to get a good idea of the numbers of soil animals of different kinds. Great care is taken not to miss any. A sieve is used to separate the animals from the soil. 1 sieve for each sample. The sieve forms the top part of a special funnel. A light bulb heats up the soil and dries it out. The animals don't like this and try to escape by moving down through the soil. They fall through the mesh, down the funnel, and into the bottle at the bottom. You need good reasons for using this method of sampling because the animals drown in the water. But it's the only way to see the very tiniest soil animals without them being surrounded by soil particles which mask the view. The animals are so small that you need a magnifying glass, or better still, a microscope to see them. To give you some idea of their size, here they are next to the eye of a small sewing needle. There it is for comparison. To make more sense of what we're looking at, we can put the animals into groups. Our first group are beetles. There are 4 different ones here. Another group is what we call the springtails. Springtails are a little smaller than the beetles and more common. Again, looking closer, we see that springtails' bodies are divided into pieces, segments. The last segment has a special job to do. We'll see how the animal uses it later. Another group is the mites. This is an even closer view because mites are much smaller than springtails. We can get a better idea of what a mite looks like by using another type of microscope. Like many soil animals, mites have their skeletons on the outside. As well as giving support, the outside skeleton acts like armor, giving protection. And if we go to an even closer view, we can see more details. This springtail has eyes. They're the bumps, but not very good eyes. Instead, it has a pair of long, thin whiskers, antennae. These give the springtail a very good sense of touch. Like many soil animals, it's very good at feeling its way round the soil. But danger lurks. A false scorpion is hunting for its food. The false scorpion feeds on other animals. It's a predator. Although the mite doesn't seem particularly bothered, probably because it's too hairy to be caught and eaten comfortably. Other animals try to get out of the way as quickly as possible. You can see how springtails got their name. The false scorpion's meal is not delayed for long. It's the natural way. Some animals eat plants. They are then eaten by other animals, the predators. These in turn are eaten by larger animals. Now for the next group of soil animals. When rain falls on the soil, it doesn't usually stay on the surface for very long. It drains away, down the holes, the burrows made by worms. Yet another reason why worms are so important. Down in the lower layers, the water spreads out between the bits of soil. If we look at the water through a powerful microscope, that's one that can magnify many times, we see yet more soil animals, the ones that actually live in the water, in the soil. These are nematodes, a type of tiny worm. You can see how tiny by again comparing them with the eye of a sewing needle, the same one as before. There's a whole variety of animals living in the water, in the soil. This is another, a tardigrade, living among the nematodes. Tardigrades are predators. They feed on nematodes. And there are even nematodes which feed on nematodes. It seems that there are many different kinds of soil animals. The next question is, how many of the animals are there? This frame measures 1 meter long by 1 meter wide. We can use it to find the number of worms in 1 square meter of soil. The ground is sprayed with water containing a chemical which trickles down into the worms' burrows, driving them to the surface. They come up from a depth of about 25 centimeters in a minute or two, although it may not bring up the worms from lower down. Now the sampling is easy. It's just a matter of picking up the worms and counting them. But how does this compare with the number of worms in a different kind of soil? And what about the animals other than worms? How many of them are there in a particular type of soil? We did a special study on a kind of soil that found in woodlands. Woodlands are more natural places to find a large number of different soil animals. The scientists chose to study a volume of 1 cubic metre of soil. That's a cube of soil 1 metre long by 1 metre wide and 1 metre deep. And the results? Worms, 128. Millipedes, 110. Snails, 100. Woodlice, 300. Ants and beetles a massive 420. But that's nothing. We have to change scale from hundreds to thousands to tens of thousands and to hundreds of thousands to fit in springtails. In a cubic metre, 200,000 of them. And even more mites, 400,000 of them. For our next group, we must change scale again to millions and tens of millions to fit in nematodes. 20 million of them live in 1 cubic metre of soil. That's only possible because they are very small. Just look how small they are against an earthworm. And the mites and springtails, although bigger than the nematodes, are themselves small compared with earthworms, which is why there are a lot of them. And remember, the scientists were looking at a piece of soil just 1 metre by 1 metre by 1 metre deep. What if they'd measured to the same depth over an area of not 1 square metre, but 1 hectare? That's 10,000 square metres. How many animals do you think they would have found? 200,000 million. And the total weight of the animals, 1,000 kilograms. That's about the weight of 2 fully grown cows. Mind you, the cows are only interested in chewing the cud. They aren't aware of the animals living beneath their noses. Even we are not particularly aware of the soil animals until they interfere with what we're doing. For instance, moles dig tunnels, which disturb and destroy young crops. And it's not just the big animals that do the damage. This onion looks all right. But when we look inside, for some reason, we find parts of it are discoloured. Back in the lab, a small sample of the onion is put on a gauze and soaked in water. And with the help of a microscope, we can see what the trouble is. Nematodes, thousands of them. Nematodes in food crops don't seem to be a particularly good idea. How would you like to eat these along with your onions? So the farmers set out to destroy the nematodes by spraying the soil with chemicals. Unfortunately, the chemicals kill large numbers of the other soil animals as well as the nematodes. Gardeners use chemicals, but in this case to help them get rid of tiny animals that live on the leaves of their crops. But what about the unnoticed effect on the animals in the soil? And there are other problems. Imagine what happens to the places where the soil animals live when the gardener digs. Or the farmer ploughs the soil, particularly when it's on a large scale in modern farms. It's not surprising that when a study of animals in farmland was done, the numbers per square metre were only 30 worms and only 2 million nematodes. Now compare that with the results from the study of woodland soil, which we saw earlier, where there were 120 worms and 20 million nematodes. So on farmland there may be fewer nematodes, but there's also fewer worms, and fewer worms can be a big problem. Remember, worms are good for the soil. They help make the soil where plants grow. Because in farmland there are fewer animals working away underground, the soil becomes poor and plants don't grow so well. So we get the funny situation where farmers have to improve the soil artificially by adding chemicals and fertilizers to do the job the soil animals should be doing. Soil scientists are still arguing about the effects all of these treatments might have on the soil and the animals that live in it. And when it comes to farmland, that supplies our food and could affect us all. It seems that the animals not only live in the soil, but play a major part in keeping it the way it is.